So here we have a trigonometric function. We need to determine its limiting value when x tends to pi over 2. So if we do a direct substitution for the value of x, we are going to get an indeterminate form, which is 0 over 0. So we're going to change the limit because it's here x is tending to a non-zero quantity. So let us change it to h. So we have h going to 0. So that would mean we'll also need to change the value of x. So x here will become pi over 2 plus h. We have the square root minus 1 divided by pi over 2 minus of pi over 2 plus h whole squared. So we now have limit h approaching 0 square root of 2 minus, so sine of pi over 2 plus h is going to give us cosine of h, and pi over 2 plus h means we are in the second quadrant. So in the second quadrant the sine function is positive, so the result of sine pi over 2 plus h is going to give us a positive. So we have positive cosine of h minus 1 divided by, so the pi over 2 and pi over 2 gets cancelled, leaving us with a negative h. So we have negative h squared, so that will be simply h squared. Now in the next step we are going to rationalize the numerator. So that would mean we have to multiply 2 minus cosine of h minus 1 by 2 minus cosine of h plus 1. So that would mean we would also have to divide by the same factor. So we have square root of 2 minus cosine of h plus 1. And we need, when we already have h squared in the denominator. Now, the numerator is of the form a minus b times a plus b. So this, if we assume this is our a and 1 as our b, then we have a minus b times a plus b, which can be reduced to a squared minus b squared. So we have limit h approaching 0. So we have square root of 2 minus cosine of h whole square. So that would give us 2 minus cosine of h minus 1 squared, which is simply 1, divided by h squared times square root of 2 minus cosine of h plus 1, which is equals to limit h approaching 0, 1 minus cosine of h divided by h squared times 1 plus square root of 2 minus cosine of h. So 1 minus cosine of h is equivalent to, we'll use the identity that 1 minus cosine of theta is equals to 2 sine squared theta over 2. So that gives us 2 times sine squared h over 2 in the numerator, divided by h squared times 1 plus square root of 2 minus cosine of h. Now what we're going to do, we're going to divide h squared by 4. So that would mean we also need to multiply by 4. That gives us 2 over 4 times limit h approaching 0 sine h over 2 divided by h over 2 whole squared. So we're applying the limit to sine h over 2 divided by h over 2 times applying limit to the second function, h tending to 0, 1 over 1 plus square root of 2 minus cosine of h. So that gives us 2 over 4, which is going to be half. The limiting value of sine h over 2 divided by h over 2 is going to be 1. So we have 1 squared times 1 over 1 plus square root of 2 minus cosine of h, cosine of 0 is going to give us 1. So which will be equals to half times 1 over, so 1 plus square root of 1, which is 1, so we have half, so our final limiting value is going to be 1 over 4. Let us do another problem. So we need to determine the limiting value of the given trigonometric function when x is approaching pi over 4. So let us begin by changing the limit from x to h. So we have h tending to 0, square root of 2 minus cosine of x. So x will get replaced by pi over 4 plus h minus sine pi over 4 plus h whole divided by pi over 4 minus of pi over 4 plus h whole squared. Now what we're going to do, we're going to expand cos of pi over 4 plus h. So we have cosine of pi over 4 plus h. So we're going to use an identity. If pi by 4 is a and h is b, then we have cosine of a plus b, which can be expanded as cosine of a times cosine of b minus sine of a times sine of b. So using that, we'll have cosine of pi over 4 times cosine of h minus sine pi over 4 times sine of h. Now we know the cosine of pi over 4 is 1 over root 2. So we have 1 over root 2 times cosine of h, and cosine of pi over 4 is sine of pi over 4 is also 1 over square root 2 times sine of h. Then we have sine pi over 4 plus h. So this can be expanded as sine a times cosine b plus cosine a times sine of b. So we have sine a, so a here is pi over 4 times cosine of b, so b here is h, plus cosine of a, which is pi over 4 times sine of b. So that gives us 1 over root 2 times cosine of h plus half, 1 over root 2 times sine h. Now we're going to substitute this value into a numerator. So let's do that. So we have limit h approaching 0 square root of 2 minus, so we have cosine of pi over 4 plus h, so that will become 1 over root 2 times cosine of h minus 1, so we have a negative here, so this will become plus 1 over square root of 2 times sine of h minus 1 over square root of 2 times cosine of h, and we have a minus, so this will be negative 1 over square root of 2 sine of h. And in the denominator, so the pi over 4 gets cancelled, so we have negative h square whole squared, so we have h squared. Now we'll see that the positive 1 over square root 2 times sine of h gets cancelled, and this is going to leave us with square root of 2 minus 2 over square root of 2 times cosine of h whole divided by h squared. This is the limit, h tending to 0. Now we take the LCM in the numerator. So we have 2 minus 2 times cosine of h divided by h squared times square root of 2. And we have the limit, h approaching 0. Now taking 2 as the common factor in the numerator, so we have 1 minus cosine of h divided by square root of 2 times h squared. Limit, h approaching 0. So we have 2 over root 2 times limit h approaching 0. Now 1 minus cosine of h, that can be replaced by 2 times sine squared h over 2 divided by h squared. Now what we're going to do, we're going to divide h squared by 4, and that would mean we have to multiply by 4 as well. So we have 2 times 2 is 4, so we have 4 divided by 4 square root of 2, limit h tends to 0, sine h over 2 divided by h over 2 whole squared. Now we know that the limiting value of sine h over 2 divided by h over 2 when h approaches 0 is going to be 1. So that leaves us with 1 over square root of 2. The 4 and 4 gets cancelled, times 1 squared. So our limiting value will be 1 over square root of 2. Let us do another problem. So here we have the trigonometric function cot of 4x minus cosine of 4x divided by pi minus 8x whole cube. So we need to find the limiting value of this given function when x approaches pi over 8. So let us begin by changing the limits. So we have limit h approaching 0. We have cot of 4 times. Now that means we need to change the limit from x to h. So we have pi over 8 plus h minus cosine of 4 times pi over 8 plus h whole divided by pi minus 8 times pi over 8 plus h whole squared, which will give us limit h approaching 0 cotangent of, so 4 times pi over 8 is going to give us pi over 2. So we have pi over 2 plus 4 of h minus cosine of pi over 2 plus 4 of h whole divided by pi minus, so 8 pi over 8 is going to give us pi minus 8 of h whole cubed, which will be equals to limit h approaching 0. Now cot of pi over 2 plus 4h is going to give us tangent of 4h. And also we are in the second quadrant, so this is 90 plus theta. So 90 plus theta means we are in the second quadrant where only the sine function is positive. So that means the cotangent function will be negative. So we are going to get a negative tangent of 4h. Then we have cosine of pi over 2 plus 4h. So that will give us sine of 4h. Then again, cosine function is negative in the second quadrant. So the result of cosine pi over 2 plus 4h is going to be negative sine of 4h. So we'll get a positive sine of 4h. Divided by, so we have negative 8, the pi and pi gets cancelled. So we have negative 8h whole cubed. So let us move further ahead. We're going to move this to the top. So we have now what we're going to do is we're going to change the tangent function to the ratio of sine and cosine. So we have limit h approaching 0, negative sine of 4h over cosine of 4h plus sine of 4h divided by negative 8 whole cubed times h cubed. Now we take the LCM in the numerator. So we have limit h tending to 0, negative sine 4h plus sine of 4h times cosine of 4h divided by negative 8 whole cubed times h cubed times cosine of 4 of h. Now we're going to take negative sine of 4h as the common factor in the numerator. So let's we have now limit h approaching 0, negative sign of 4h. So we're going to take this as the common factor. That leaves us with 1 minus cosine of 4h divided by, so negative 8 whole cube will be negative times 8 cubed times h cubed times cosine of 4 of h. So we can get rid of the negative sign by multiplying both numerator and the denominator by negative 1. Now we have 1 over 8 cubed. So we have taken it out of the limit. So we have limit h tending to 0, sine of 4h. Now we have 1 minus cosine of 4h. So that will be equivalent to 2 times sine squared twice of h. So this is the half angle formula, divided by h cubes times cosine of 4 of h. So now we're going to arrange all of them. So let's do the arrangement here. So we get rid of the extra ones. So we're going to rewrite it as 1 over 8 cube times limit h approaching 0. So we have sine of 4h divided by h. So 2 can be taken to the front. So we have 2 over 8 cube. We have sine squared 2h. So let's break it down as the product of sine 2h and 2h. So we have sine 2h over h times sine of 2h over h times 1 over cosine of 4 of h. So now we are going to multiply sine 4 of h over h. So we're going to multiply the denominator by 4, but that would mean we need to multiply by 4. We will multiply h by 2 and multiply the entire function by 2. Similarly, we multiply by 2 and multiply the entire function by 2. Now we have 2 times 4 times 2 times 2 divided by 8 cubed, so which is 8 times 8 times 8 times limit h approaching 0. We have sine 4 of h divided by 4 of h times the limit h approaching 0, sine of 2 of h divided by 2 of h. So this is happening twice, so let's take the square, and the final function limit h approaching 0, 1 over cosine of 4h. Now we know that the limiting value of sine 4h over 4h, this is going to be equals to 1. Similarly, sine 2h over 2h, the limiting value is going to be 1. And when we substitute the value of h in cosine of 4h, so we're going to get 1 over cosine of 0, which is also going to be equals to 1. Now that leaves us with only the constant term. So 2 times 4 is 8, and 2 times 2 is 4, and 4 times 2 is 8. So we are left with 1 over 16. So this is going to be the limiting value of our given function when x approaches pi over 8. Let us do another one. So here we have cosine of x minus cosine of a divided by square root of x minus square root of a. We did determine the limiting value when x approaches a. So let us begin by changing the limit from x to h. So we have h tending to 0. So the x will get replaced by h plus a minus cosine of a divided by square root of a plus h minus the square root of a. Now we're going to use this identity that cosine of a plus we have a minus here, so we have sine of A minus cosine of B is equivalent to negative 2 times sine A plus B over 2 times sine A minus B over 2. So let's use it, and this is going to give us limit h approaching 0. We have negative 2 times sine of h plus a divided by 2 times sine of h plus a minus a divided by 2 divided by square root of a plus h minus the square root of a. Now this will give us limit h approaching 0, negative 2 times sine twice of a plus h over 2 times sine of h over 2 divided by square root of a plus h minus the square root of a. So the next step will be to rationalize the denominator. So let us do that. So we're going to multiply the numerator and the denominator by the conjugate of the denominator. So we have negative 2 sine 2a plus h over 2 times sine of h over 2 divided by square root of a plus h minus the square root of a. So the conjugate will be square root of a plus h plus square root of a. And similarly, we multiply to the numerator. So square root of a plus h plus the square root of a. Now that converts the denominator to limit h goes to 0, negative 2 sine 2a plus h over 2 times sine h over 2 times square root of a plus h plus the square root of a divided by, so we have two functions. So we have a minus b times a plus b, so that becomes simply a plus h minus a. So the a and a gets cancelled, leaving us with only h in the denominator. So we have h. Now we can bring the 2 from the numerator and divide both. What we can do is divide both the numerator and the denominator by 2. So we'll have an h over 2 in the denominator. So I can get rid of this 2. So we have negative in the numerator and sine h. So this was done so that we can convert the sine h over 2 divided by sine h over 2. So we can use the limiting value, which is going to be equals to 1. So let's do that. So we'll have negative limit h approaching 0 sine 2a plus h over 2 times limit h approaching 0 square root of a plus h plus the square root of a sine h over 2 divided by h over 2. The limiting value went to 1. So we have negative sine of 2a over 2 times square root of a plus the square root of a. So the final answer will be negative 2 times square root of a times sine of a. So this is going to be the limiting value of a given function when x approaches a. So in this question, we need to determine the limiting value of the given function when x approaches pi. So let us begin by changing the limit. So we have limit h tending to 0, 5 plus cosine of, so x will get replaced by pi plus h. So everything is under square root, minus 2 pi minus, so we have pi plus h whole squared, which will be equals to limit h approaching 0, square root of 5. The cosine of pi plus h is cosine of h, so cosine of pi plus h is actually in the third quadrant where only the tangent function is positive, everything else is negative, so we'll get negative cosine of h minus 2 divided by, so the pi and pi gets cancelled, leaving us with negative h whole squared. Now we're going to rationalize the numerator. So we have limit h approaching 0, square root of 5 minus cosine of h minus 2 whole multiplied to square root of 5 minus cosine of h plus 2 divided by h squared times square root of 5 minus cosine of h plus 2. Now we can simplify the numerator. So the numerator is in the form of a minus b times a plus b, so which reduces to a squared minus b squared. So we have limit h approaching 0, so we have 5 minus cosine of h, the square root of which square root and whole squared, minus 2 whole squared divided by h squared times square root of 5 minus cosine of h plus 2. So that will give us limit h approaches 0. So we have 5 minus cosine of h minus 4 divided by h squared times square root of 5 minus cosine of h plus 2. Arranging the numerator, so we have, so the numerator will now become limit h approaching 0, so we have 1 minus cosine of h divided by h squared times 2 plus square root of 5 minus cosine of h. Now we know that 1 minus cosine of h is equals to 2 times sine squared h over 2 divided by h squared times 2 plus square root of 5 minus cosine of h. So we're going to divide the denominator, which is h squared, by 4, and we're going to multiply by 4. So that finally gives us 2 over 4 times the limit h approaching 0. So we have sine h over 2 divided by h over 2. So this is repeating. So we have a whole squared here times the limiting value of the function 1 over 2 times square root of 5 minus cosine of h. So we have 2 over 4, so that will be half. Limiting value of sine h over 2 divided by h over 2 is going to be 1 times 1 over 2 plus square root of 5 minus cosine of 0, which is 1. So we have half multiplied to 1 over 2 plus square root of 4, which is 2. So we have half multiplied to 4, so that gives us 1 over 8. So this is going to be the limiting value of a given function when x approaches